In this video, we're going to evaluate inverse trigonometric functions. It says evaluate sine, tangent inverse of -1. Enter an exact answer. Now, because they have tangent inverse here, we need to know that the domain for tangent inverse lies between -pi/2 and pi/2. So because that's the case, if we look at the unit circle, those two spots would be right here. This is -pi/2 and this is pi/2. We're going to have an angle for an answer that is either a positive radian between 0 and pi/2 or a negative radian between 0 and -pi/2. We cannot go all the way around the circle and say that we're at 7 pi/4. If our answer is 7 pi/4, we'd have to say that that's -pi/4. So that's something to be aware of, that I have to stay in this region because of the tangent inverse. So tangent inverse, I can start with this, of -1 is really equal to theta. So that means that the tangent theta would be -1. If I look on the unit circle, tangent is 1 at pi/4. It's -1 at 3 pi/4, and also -1 at 7 pi/4. But 3 pi/4 is not between -pi/2 and pi/2. It's in the second quadrant. We're looking at quadrants just 1 and 4. So quadrant 4, 7 pi/4 is the angle that we want to use here, but we can't use 7 pi/4 because that implies going all the way around the circle into regions that that aren't part of tangent's domain. So we actually want to go clockwise on the circle, which would be -pi/4. So -pi/4 is a coterminal angle with 7 pi/4. So we can say that this is really just sine. So we can say theta would equal -pi/4 there. So that means that sine of -pi/4 is what we need to evaluate next. Well, if I go to -pi/4 and look at sine, that's -√2/2. So that means that this is really just -√2/2 for the solution. So we can say sine tangent inverse of -1 is equal to -√2/2.